Hi, this is Mrs. Cribb, and this is the video lecture for 2C, the states of matter, or the common states of matter. We're going to be covering solids, liquids, and gases, and plasma. Now notice how solids are all packed together very closely. The liquids they're very close together as well, but they're kind of rolling around. They're not in a fixed shape. Gases are flying around. They fill up whatever container they're in. And then plasma, which is made out of ions and electrons, they're moving very fast. They also fill up whatever container. Solids hold their fixed shape. A liquid will take the shape of whatever the container is, and gases will also take the shape of whatever the container is and fill it all in. A solid has a very fixed volume. A liquid has a fixed volume, but a gas doesn't, because it'll expand and keep expanding to fill whatever it's in. So this is part of the kinetic molecular theory. This is very important, kinetic molecular theory. I'm going to go back to the notes for a minute to this portion. So this is where I can write on, Kinetic molecular theory. All matter is made of microscopic particles that are in constant motion. Even solids, guys, even solids. Okay? If you add energy, they will speed up. If you make them hotter, they go faster. Atoms, molecules, and ions are attracted to each other by electrical forces, positives and negatives, and it keeps them from flying apart. Okay? Solids have very little of this energy, and they're compared to their attractive forces. That means the things that are holding them together are stronger than the energy they have to fly apart. But they still vibrate. Okay? Attractive forces have to overpower the kinetic energy. That's that movement energy. Remember that? Of the particles. So if the particles are trying to fly apart, but the kinetic energy, the movement energy is not strong enough, the solids are going to stay stuck together. Particles, they're in a fixed position. They stay in the same shape. They're not compressible. They're incompressible because I can't squish them because they're already stuck together. They're squeezed together already. I can't make them go any closer. And when enough energy is added, a solid becomes a liquid because of melting. Okay? When enough energy is added, a solid becomes a liquid. And then liquids have more energy than a solid. So if we put the energy scale like over here, where we have solids, they have less energy than a liquid. Okay? A liquid has more energy than a solid. Liquid particles are limited in motion, though. They kind of flow, they roll around each other, so they have the ability to flow. Liquids flow. Fluids flow. Fluids flow. Liquids are fluids. And they're nearly incompressible, so just like solids, they're almost incompressible because they're so close together still. Think about a glass of water. It's hard to push that water even closer together. They don't have a fixed shape because they change according to the container. So if I have an Erlenmeyer flask that looks something like this, and I have a liquid in it, it will take this shape in the flask. But if I pour it into a really tall test tube, it will take this shape. So whatever shape the liquid is poured into, it will fill that shape. They do not have fixed shape. And give the particles enough energy and they will fly apart and become a gas. So solids have less energy than liquids. Liquids have less energy than gases, and that's next. Okay, gas particles have very high kinetic energy, movement. They move really fast. They fly away from each other. Look at this. At the average velocity, at 25 degrees Celsius, the average velocity of an oxygen molecule, remember oxygen is O2, it is diatomic. What are those diatomic elements again? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, when oxygen, one of those diatomic elements, at 25 degrees Celsius, it's moving 993 miles per hour. That's pretty fast. As gases fill up their container through diffusion, remember from diffusion they go from a concentrated area and then they diffuse until they're all spread out to an unconcentrated area, an area of low concentration. They are highly compressible. Why are gases so compressible? because one gas molecule is here and one gas molecule is here, and look at all this empty space. They can be pushed together. Okay? And gases flow. Gases are fluids, and hopefully you were in class and we did the iodine sublimation experiment. It's really just a demonstration, and you can watch that gas flow. So gases flow, so they're fluids. What else flows because it's a fluid? Liquids flow, so it's a fluid. So gases and liquids are fluids, but what's not a fluid? A solid. Solids are not fluids. They can't flow. They just plop. They fall down. Plasma. So we'll illustrate the 3 states of matter in a glass of ice water real quick in a minute. So I'm just going to draw it off to the side here. We have a glass of water. We'll have a liquid contained inside of there. And we'll have some ice cubes floating on top because ice is less dense than the liquid water. Now, on the outside, we're going to have some water molecules right here, or air molecules. And then also some water molecules or water vapor right above the liquid. So in this glass, we have liquid water, we have solid water in the ice cubes, and we have water vapor or gaseous water right above it. If enough thermal energy is added to a gas, the electrons of atoms are stripped away and becomes a plasma. So that's the 4th state of matter. 4th state of matter, one we don't talk about a lot. It's actually the most common one because stars are made of plasma, and stars are huge compared to planets. It's found in the sun, in thermonuclear fusion, in neon signs, fluorescent lighting, plasma screens, all kinds of things. All right, the common changes of common states of matter. We'll go through that in just a minute. Let me go back to the Prezi. So here's the notes we just went through, and we're going to go through a couple of videos, hopefully.
The kinetic molecular theory is the theory that all matter is composed of atoms and molecules that are in constant motion. The particles move at random and hold kinetic energy. The more energy a particle has, the more and faster it will move. In solids, such as ice, the molecules hardly move at all and hold a regular pattern because the energy is low and the molecules are tightly packed. In a liquid, like water, the molecules have freedom to move around and have more energy. Liquids have the ability to fill any shape of any container they are put in. In gases like steam, the molecules have the most energy. Gases can expand and compress to fill any container. All matter contains atoms and molecules that are moving. The warmer the temperature, the more energy these particles have, and that is the kinetic molecular theory.
Okay, and now we're going to do this next one.
The stuff that everything's made of, is made up of many tiny particles. The behavior of these particles is what makes a substance a solid, a liquid, or a gas. In a solid, the particles are packed closely together in a rigid structure, vibrating about fixed points, but unable to move around. In a liquid, the particles can move around each other, so the liquid has no fixed shape, but they're still very close together. But in a gas, the particles are spread far apart, moving around rapidly and randomly to fill the entire space.
Everything around us can exist in the 3 states of matter: solid, liquid, and gas.
Okay, we have one more video that we're going to watch.
Okay, class, this is the quick simulation about the kinetic molecular theory. What we have here, I want you to notice, is a simulation from the PhET, P-H-E-T, which you can log on yourself. In fact, I can move this down. There it is, P-H-E-T. You could log on as a student and get an account and do some of these simulations. What I want you to notice is a couple things. First, look at the different molecules. This is neon that's currently in here. I could put argon in there. I could put oxygen, which is diatomic. Remember, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Or I could put a water molecule in here. And we're going to go through the different states of matter. So I'm going to go back to neon. Notice at the top here, the temperature is in kelvins. And we can add heat by rolling this up, or we can cool it off by just moving this up and down. And we're going to see what happens. Now, the kinetic molecular theory says that solids are rigidly shaped. They have a fixed volume and a fixed shape, and you know that's true. Your calculator is a shape like a calculator, and no matter what you do, it's shaped like a calculator. It's a solid. I can't pour the calculator out. Now, if I add heat to something, notice first of all this solid of neon, all the molecules are wiggling and moving because everything's moving. Everything has kinetic energy. If I add heat to this, though, the temperature is going to begin to go up at the top. Now it's, look here, it's 26 kelvins now. The molecules are gaining more heat energy. They're moving more. They're moving more rapidly. If I keep adding heat, they're going to get more and more energy until they start to act like a liquid, okay? And liquids are able to flow, and some of them get enough energy they fly off, okay? So let's look at a liquid. A liquid, it doesn't have a fixed shape. It has a fixed volume, the same number of particles, but the shape is going to change as you add the energy to it. And if you add even more heat, that liquid, all the particles in there get more and more kinetic energy until they have enough energy to break apart from each other and fly apart and fill up the container. And so eventually you have a gas. And when you have a gas, all the particles are flying randomly and hitting containers, and they're filling up the entire container. So a gas has no fixed shape and no fixed volume. In fact, if I open up a container, all of the gas would fly out and start to fill in the bigger container. So let's go back to liquid. No fixed shape, but definitely a fixed volume. It's not going to get bigger than this. It's just going to, squash and reshape, but it's always going to be this size. Think about filling up your Coke or your water into a water bottle, pouring that water out onto the desk. You still have the same amount of water, but now the shape of the water changed. A solid has the fixed shape. You have a cube of ice. It's a solid. You pour that cube of ice onto the table, you still have a cube of ice sitting on that table. It had the same shape and the same volume. Liquid, same volume, different shapes. Gases, no fixed shape, no fixed volume. And what's the difference between them? When you add heat, you increase the kinetic molecular energy, so the particles don't stick together well anymore, and they start to pull apart. They have enough energy to get away from each other and fly apart and fill up their container. So we can also do argon this way. There's argon as a gas, as a liquid, and as a solid.
Okay, I'm going to stop it there, and if you want to go farther and go back to that site and play around, we can do some more. But this site is also this video is embedded into the Prezi, so you can go back and look at the original Prezi. Alright, this is one of those silly songs, okay, that you can learn, memorize, and sing it for me for some extra points.
Gas, liquid, solid, the states of matter. I've got gas, liquid, solid. I've got gas.
Now, I'm not going to continue on with this one because if you want to learn, this is actually kind of a fun little video that these guys made for their chemistry class. So you can go back and watch the Prezi and learn this song for some extra credit. If we have time, I might play it in class at some point. So this brings us to the common, the changes of the common states of matter. Whoops. There we go. Changes to common states of matter. So here we go. It's all matter. See how we're adding energy or adding heat down here? Heat energy. So if we add it, we add heat, a solid will melt and turn to a liquid. Then a liquid will vaporize and turn into a gas. And a gas will ionize and turn into a plasma. So that's adding heat. It's getting hotter and hotter and hotter. And if I take the heat away, it will deionize or turn from ions, like cations and anions we'll talk about later. So it'll go from a plasma to a gas. If I take more heat away, see here, in opposite direction, I'm removing heat. Okay, so if I take more heat away, the gas condenses to become a liquid. If I take more heat away, the liquid freezes to become a solid. Now the other thing is a solid can actually go straight from a solid to a gas, and that's sublimation, and that's my iodine experiment or demonstration. And you can also do that with dry ice. And the opposite of going from straight from a solid to a gas is going from a gas to a solid, and that's deposition. Okay, so you need to memorize these terms, and we'll do a little bit of demonstrations in class. And that's really the end of this chapter's notes, so it's not too bad, not a too hard chapter. Spend plenty of time on the Prezzi's Quizlet, which, ta-da, there it is. I'm going to click on it and take you there. Click on it. Here's the Quizlet for Chemistry Chapter 2. Notice it was the last slide. Here are all the different slides that you can use and learn things about this chapter in it, using it. It's not too terrible, but this is a good study tool. So please spend time practicing and getting ready for the test. I will see you soon. That's all there is.